This lesson discusses amplitude and period for trig functions using Alex. All right, over here in the corner, I have a basic sine function, and the basic sine functions, the wave kind of starts at zero, sort of. It's a continuous wave. It never starts at a particular point. So to say that it starts at 0, 0 isn't true. It keeps going. So anyway, I started here at 0, 0, and then it goes up to 1 and down at pi to 0 again, and at 3 pi over 2 it's at negative 1, and then at 2 pi it's back to 0. So the trig graph usually counts by pi over 2. You can count by anything you want, but usually, just like we'll count by 1s or 5s or 10s, I'm going to count by pi over 2 on it, and that's the basic graph. Usually it counts by that. The amplitude is how far, how the max minus the min, and you divide by 2. So the amplitude, it goes from 1 down to negative 1. So a half of the max minus the min, the amplitude is 1. And that's the number in front of the sign, and there's no number in front of it, so it's a 1. So y equals a sine bx, and a is the amplitude. B changes the period of the function and makes it tighter or wider. So on this one, the amplitude's 2/3, and the period on it, since there's a 3 there for the b value, the formula for period is 2 pi over b, and b is 3, so the period on it is 2 pi over 3. So every 2 pi over 3, the sine wave is going to repeat. So looking at that on our calculator here, going to y equals, the basic sine wave, again, let's look at that. You're going to want to change your zoom down here to trig number 7, and then it graphs the basic sine wave, and it's counting on your calculator by pi over 2. So the first tick mark's pi over 2, pi, 3 pi over 2, 2 pi. All right, so putting in the new graph here for 2/3, 2 divided by 3 sine x. And I'm going to make it thicker in the front here so you can see it compared to that one. Oh, I forgot the 3x on it. Son of a gun. All right, 3x. There we go. So there's the basic sine wave. And here's the new one. It's a lot tighter because it's got a shorter period on it. So it actually makes about 6 sine waves across the whole thing. Instead of the original sine wave, we just got 2 complete waves of sine. On this one, there's 6 full waves of sine there on the picture. So it lowered the height of it from 1 down to 2/3, and it made it tighter. So it repeated more often. On the next one here. So on the next one, cleaning it up, I put this chunk in the front for fun. Negative 4 sine 2x plus pi over 2, and then I moved the minus 2 to the back. So that's the amplitude there, 4. And then on the inside of it here, you've got to divide out the 2, because that's the b. The number in front of the x is the b, but you have to pull it out. So I divided or factored out 2 from all of it, which made x plus pi over 4. 2 divided by 2 is 1x, and then 1/2 divided by 2 is 1/4. So that's the b. And using the formula again for period, 2 pi over b, 2 pi over 2 makes pi. And then the phase shift, the number that's added or subtracted from x is the phase shift. That shifts it left and right. The phase shift goes left and right. So that is opposite of plus pi over 4. It made it negative pi over 4. On the next one, they want us to make the equation given the graph. And you get to choose either sine or cosine. I chose to do sine. It starts at 0, 0, and that's where sine starts at. So it's easiest just to go with sine. And the amplitude here is 5, or you can do the max 5 minus the min, which is negative 5, and take half of it, and it's 5. The period on it, how often it repeats, it started at 0, it ended at 4 pi. So the period on it was 4 pi. And so that equals the formula 2 pi over b. I'm going to switch the b and the period. They're across from each other. They're cross products, so you can just switch them. So that makes it 2 pi over 4 pi. Cancel on the pi, so b is 1/2. So that makes the function y equals sine of 1/2 x. On the back, it's the same question again. This time I went for the cosine wave because the cosine wave starts at 1, ends at 1, and in between at pi, it's down at -1. So the easiest one to use on this is cosine. It starts at 5, it ends down at -1. So doing the amplitude on it, it makes a 3. 5 minus -1 and take a half of it, it's 3. And then the period on it, to make a full wave of cosine, it started at 0, it ends at pi. So 1 period of this was pi, and that equals that formula then, 2 pi over b. Again, flip the cross product, so that makes b equals 2 pi over pi, which is just 2. Then on top of that, it had a vertical shift of 2. It wasn't, the center of it wasn't here on the x-axis. It flipped, it went up all the way to the number 2. So it had a vertical shift up 2. So that makes the whole thing 3 cosine 2x plus 2. Amplitude was 2, vertical shift up plus 2, and the b value was 2. Next up, we have a buoy floating in the ocean is bobbing in simple harmonic motion with period 8 seconds and amplitude 4 feet. Its displacement d from sea level at time 0 seconds is -4 feet. And initially it moves upward. Note that upward is the positive direction. Give the equation modeling the displacement d as a function of time, t. So I made a graph of it. So I used counting here, I counted by 1, so it made a full wave by the time it got to 8. It started, it said, at -4. So making the harmonic wave, it goes, and I divided that 8 up then, I divided it by 4 to make 4 sections of it. That's kind of the trick when you're doing sine and cosine waves, divide the numbers by 4. So every 2 it changed. So going over 2, it's at 0, go over 2 more, it's up at 4, over 2 more, it's back down to 0, and over 2 more, it's down to -4. That's more than you even had to do on the problem. It was overachieving what I just did. But they said that the period on it was 8. So 8 equals 2 pi over b. Again, flip the b and the 8, and so that makes b pi over 4. The amplitude they told us was 4. The fact that it starts down here at -4 instead of at +4 for cosine, it flipped it. So it reflected over the x-axis, which made that a -4. So -4 cosine pi over 4t. On number 6, it says the population sizes of many animal species rise and fall over time. Suppose the population size of a certain species can be modeled by the following function: 2,220 minus 1,120 sine 0.7t. So again, I just rearranged the chunk. It made me happy. So -1120 sine 0.7t plus 2,220. So the amplitude is 1120. The b is 0.7, so I put 0.7 down here, 2 pi over 0.7, which makes 27. So you can use your calculator if you want. 2 divided by 0.7, hit math, enter, enter, and that's 27ths. Or if you want to, it's 2 over 1 times 7/10. So you got to, well, divided by 7/10. So it makes it times 10 over 7 when you flip it over, which is 27ths. So answering their questions down here, 1 full period of the function is 20 pi over 7. Put that in your calculator, 20, use your pi key, 20 times pi divided by 7, and you get this number. So the nearest hundredth, it's 8.98. And then how many cycles per year? Well, in 1 year we had 8, so we're going to have per year. You're not even going to get a full cycle in a year because you're doing 8 full cycles in it takes 8 years to get a full cycle. So again, you don't even get a full cycle in a year. So 1 divided by 8.98, you only get a 0.11 of a cycle in a year. Your max is going to be your vertical displacement plus the amplitude. The minimum, which they didn't ask for, but the minimum would be the vertical displacement minus the amplitude. So the amplitude here was 2,000, well, the vertical displacement was 2,220 because it went up 2,220, so that's the vertical displacement. And then we're adding to it the amplitude, which makes the answer then 3,340. And the next 6 questions just repeated the other 6 questions on it. So that gives you 6 more tries to do it. Again, use the explanations on Alex to help you out. Watch the video again a second time to think about them. And if you need to, we can have some office time on Zoom this week. You have a good week. Bye-bye.